Hi, this is your Swapnil Bharti, and we are here at KubeCon CloudNativeCon in Atlanta. And today we have with us Severin Neumann, Head of Community at Causal. Severin, it's great to have you on the show.
Yeah, happy to be here.
The landscape is changing. When we look at the whole SRE,
Yeah.
folks are drowning in alerts. It's not. I mean, when you look at the Kubernetes ecosystem, you cannot scale in a traditional means. So we have to take help from AI. Can you talk about, first of all, what does AI-SRE actually mean?
What I always like to start with here is like, what does AI-SRE not mean, right? And it's not meaning like, hey, we have here an LLM that's doing on-call for you, right? Because there's a lot of solutions out there that say like, oh, let's do an AI-SRE. And what we do is like, we give all the data that we have, alerts and observability data into an LLM, and then suddenly it does some magic for us, right? So we think that like, if you talk about AI-SRE, you should look at the whole SRE discipline and talk about like, what does it mean to be an SRE? And you want to be proactive, you want to predict things happening, you want to shift the whole reliability left and make sure that your software is reliable when you roll it out, right? And that's where AI should help you. That's where AI should look at your code and say like, wait a minute, before you roll out your stuff, here's a few things that you can do to increase the reliability of your application.
How does AI-SRE change the game for DevOps and SRE teams as compared to the way they have been doing things traditional? We can use the word traditional.
I think the big difference again is like, so I've been in like especially the observability and monitoring space for a decade now, and people like to talk about predicting things and being proactive about things. But let's be honest, that's not a reality, right? Most of the things are like, hey, there's an alert, let's react on that. And then like we are happy again. But the interesting thing now with good AI-SRE solutions is that like, you can really look at the data that you have. And of course you solve incidents with it, right? It's helping you to pinpoint the problem, but it's also really helping you to that like when things are normal, to really look at the vast data you have and say like, oh, here are your bottlenecks. Here are the things that will break next, right? Here are the things where you can increase your reliability. So we are changing that game from that perspective.
Other folks are also experimenting and playing with AI-SRE.
Yeah.
What is Causal's kind of differentiator, the whole causal reasoning, and also how is it also different from the traditional whole standard machine learning? Or if you can talk about anomaly detection that we see in AI ops mostly.
So the thing like what's very different about Causal, like we call what we do a causal model or causal reasoning. And very quickly people say like, oh, you use an LLM to reason about the data that we have in our systems. And that's what we not do, right? So what our causal model is, this is just another way of machine learning, another way of AI that you say like, hey, we have a generic so-called causal model where we understand like how certain components in your environment, for example, in a Kubernetes cluster, interact with each other and what is impacting what in what situation. And then we apply that to a real system of a customer, of an end user. And then when symptoms show up in that system, like when they have like 10, 20, 100 symptoms, we can use that model to map all those symptoms to the one cause that explains them, right? And you don't use an LLM for that because LLMs are good at correlations. They're good at pattern matching. But what we do is really like this causal inference to say like, hey, those are the symptoms, and here's like the cause that explains them. So it's much more deterministic. And that's where we like differentiate from the other solutions. Where we use LLMs is at the end of that, right? So we create like, we understand like what's going on in your system. We identify that one root cause, that explains the symptoms. And then of course we want to give people an explanation. Then we want to give people a remediation and say like, hey, in your Kubernetes cluster, you have to scale something up, or you have to update a version of something. And LLMs are good at that, right? They're good at like giving you an explanation. They are good in like creating the synthesis, and they are good like, hey, run this command on your cluster and you're back to normal, or run this command on your cluster and you increase the reliability in your system.
Are other companies also leaning towards causal reasoning? If not, why is it like harder than, kind of
I mean, I'm an expert on Causal, right? And of course, I have an overview of the competitors. I cannot say if there's others that are doing it, but I'm not aware of them. So I'm not really aware of any others that are like doing it in that way that we are doing it. And I think one of the main reasons is that like the moment people say AI, they think about LLMs, right? And to some extent, it's very natural to say like, oh, look at it. We have all this observability data. We have all this data that's flowing in from our systems. And LLMs are good at like taking all this data and making it smaller and more concise. Why not use an LLM for that, right? And they have to burn their fingers first to figure out like, yeah, that's not working, right? And that's like a lot of people we talked to went through that already, right? They went already through that thing where they said like, I said they used a competitor or they used, many built their own thing, right? And some of them are successful up to a certain point because it works up to a certain point. But sometimes you know how LLMs are. They can hallucinate. They can mislead you. And that's the worst thing that can happen, especially in an incident, right? Imagine you're 3 hours chasing the wrong thing. That's costing you a lot of money.
Now, you folks also launched the MCP server here at KubeCon.
Yeah.
Talk a bit about what it is and how does it work for Kubernetes remediation?
The thing about MCP is like everybody is right now looking for their use case for it, right? But the cool thing about MCP is what I also like about it. It's like this kind of very agnostic protocol, how you can make AIs work with each other, right? And the thing what I mentioned before, right? So we have our causal reasoning engine, and the causal reasoning engine is giving you like that cause that explains your symptoms. And now you can use MCP and get this information into your IDE or into your command line. And then it can tell you like, hey, here's the problem. And here's now the Kubernetes command. Here's now the Helm chart command that you can apply to remediate the thing that's happening, right? And that's how we envision it, right? That like you can use the Helm charts, use the kubectl that you have already, but enrich it with the knowledge that Causal is giving you, right? And really shortcutting that time where you're like, oh, I have to look through my logs and to my traces and metrics and all the information the cluster is giving me. Causal is doing that on your behalf. And then it can tell you like, hey, here's the thing that you need to do. And then hopefully at some point, the next step for us at least is like, at some point, you can give it boundaries and say like, hey, at some point I take the human out, right? I can say like, hey, I give the LLM and I give Causal some boundaries, and within them, it can scale up, scale down, it can add memory, remove memory, it can update certain things, etc., right? And that's changing the game in your Kubernetes cluster because you're not like poking around anymore. Like you're not doing, I love calling it explorative debugging, right? Where you're like maybe in your test environment, just trying out things, then you try them out in your production system. That's how we change the game.
Is it possible for you to give some real life examples, if something goes wrong, how does Causal come and help? And how does that fix look like for developers, sorry?
I mean, there's many examples, but maybe let's keep it fairly simple, right? Let's say you have a very complex microservice architecture, right? Let's say you have a few hundred services running on your cluster, and suddenly everything gets yellow, red, whatever, and you get your classic alerts of like, hey, end users are impacted. I don't know, maybe a financial institution and like people can no longer send money to your friends or something like that. And what Causal now can tell you, like across all those services running on your cluster, it can say like, hey, it's this one service here, maybe your fraud detection or something like that. And it's a bottleneck because like it's spammed with requests from the other services. And here's the one Kubernetes command that you have to run to scale it up. Or here's the one Kubernetes command that you have to run to increase the memory of it, right? So that's how we do it.
You're also open telemetry maintainer, right?
Yeah.
In the beginning, humans play a very critical role. When we bring AI into picture, what is the role of human SRE when we are embracing MCPs and when we're looking at AI-SREs?
I think like what I said, like at the end, like the SREs have to build trust upon the AI, and then at some point remove themselves in situations where they're no longer needed because they can say like, hey, I have the the certainty that causally and my LLM are able to do those things, and I can focus on new things. So they're more like an orchestrator. They're more like figuring out like how and where can I remove myself and rely on AI, and what are the other places where I need to focus. And then they, of course, can do other things and focus on other things like getting better at defining their SLOs, right? There are so many companies out there that say like, oh, we want to do SLOs, but we never get to it because we're chasing one alert after the other. They can look into that, or they can spend more time in already building in reliability into their services before they deploy them, right? They can consult teams in their company about what do they need to do to build reliable services, right? And you get out of this constant firefighting mode.
Severin, thank you so much for joining me. It's quite obvious by now after listening to you that when we look at AI-driven SRE, it's not just trying to find, but it's more about automating the fix in a manner that actually augments the SRE engineers, SRE teams. So really appreciate your time today, and I look forward to chatting with you again.
Thank you for having me. It was
My
great.
pleasure. Yeah. And back to our audience, if you are facing challenges when it comes to Kubernetes, you should check out Causal. Thanks for watching, and we'll see you in the next video.